Hello, my name is Mama Aikan Azwan. Today, I would like to present the making of sodium chloride salt crystal. Before we dive into the details, let me give you a brief overview of what to expect. I will be discussing the procedures, results, and by the end of this presentation, I hope you will have a clear understanding of the properties of sodium chloride salt. This topic is important to me because it helps us to understand the process of salt crystal formation. I'm excited to share this with you and hope you find it as interesting as I do. Let's get started. For introduction part, evaporation of a saturated solution results in the ordered deposition of solute particles into a solid lattice structure, which forms salt crystals. When a solute like salt dissolves in a solvent like water, a homogeneous mixture is created, starting the process. The solute particles precipitate out in a repeating geometric configuration, which is typical of crystalline structures. As the solvent evaporates and the solubility limit is exceeded, the size and form of the resultant crystals are influenced by temperature, surface area, and evaporation rate. We use only two main items in the making of sodium chloride salt crystals. The first one is salt, the key ingredient for our solution. Second is hot water, used to dissolve the salt effectively and speed up the process. This simple apparatus was sufficient to carry out the process and demonstrate the face-centered cubic arrangement of salt. Now let's move on to the procedure. The steps are straightforward and easy to follow. First, take a jar or glass and fill it with warm water. Make sure it's not too hot, just warm enough to dissolve salt easily, and add 3 to 5 teaspoons of salt depending on the size of your container. For best result, you want to make sure there's enough salt to create a saturated solution. If you are working with a large amount of salt water, you may need to use a larger container to allow for better evaporation. Next, use a spoon to stir the water thoroughly. Continue stirring until the salt is completely dissolved and the solution appears clear without any leftover salt at the bottom of the container. Double check that no salt has settled at the bottom of the container. It should all be dissolved in the water. Ensure that the solution is thoroughly mixed before placing in the sun. The last step is find a spot outdoors where the solution will be exposed to direct sunlight. Make sure the container is placed securely in the sun, where it can stay undisturbed. Over time, the sun's heat will cause the water to evaporate, leaving behind salt crystal. This process can take several days depending on the weather and how much water you started with. Next, we will be looking at the changes in size and appearance over 3 key time points: after 6 hours, after 1 day, and after 5 days. Let's take a look at the result. After just 6 hours of growth, we observe that the crystals have already begun to form their cubic shape. The surfaces are smooth and have a white. At this stage, the crystal size has increased slightly. The smooth white surface suggests that the crystal structure is still in the early stage of growth. After 1 day, the growth of the crystals is significantly more pronounced. The crystals have grown and their cubic shape is much clearer. The surface remains white and smooth, and the increase in size indicates that the crystal is still actively growing and forming. After 5 days of growth, we see a substantial increase in the size of the crystal. The cubic shape is well defined, and the surface remains consistently smooth and white, reflecting the purity and regularity of the crystal structure. Over the course of these 5 days, the growth has been steady, and the crystals have reached a mature stage where their form and appearance are almost fully developed. In conclusion, the crystal growth process over 6 hours, 1 day, and 5 days shows a clear trend of increasing size and well-maintained surface quality. From the initial stage, where the crystals are small and their shape is less defined, to the final stage after 5 days, where they have grown significantly and taken on their cubic form. We can observe how time plays a crucial role in the development of the crystal structure. This experiment not only showcases the growth of these crystals, but also highlights the importance of time in shaping the final product. How does a solution of salt form cubic-shaped crystals, and why are the surface of the crystal white and smooth? The explanation. How soon the crystals form is determined by the continuous rate of water evaporation in the solution. Crystals of almost the same size will result from comparable growth circumstances for all crystals if the rate of evaporation is constant across the surface. Is salt FCC or does it have a different crystal structure? Salt, specifically sodium chloride, is considered to have an FCC face-centered cubic crystal structure due to the arrangement of its ions. First, sodium chloride is made of sodium ions, Na+, and chloride ions, Cn-. These ions arrange themselves in a way that maximizes stability through electrostatic attractions, positive and negative charge attract. The FCC arrangement of sodium chloride. The chloride ions form a cubic lattice, which is essentially a face-centered cubic arrangement. Sodium ions occupy the spaces between the chloride ions in the octahedral voids of the cubic lattice. Ions are densely packed to minimize repulsion and maximize attraction.